Hello everyone, welcome to coding interview in 5 minutes. I will guide you through the coding interview from the interviewer's perspective. I'm an ex-Google interviewer and currently I'm a senior engineer at FAANG and I've got offers from several large companies. Okay, today we will take a look at the two-sum and illustrate how we use 4 different methods to show our think-through chain to the interviewer to demonstrate our logic. The first method is a brute force, where we exhaustively iterate the first IDX and the second IDX to find the target. However, how can we do better than brute force? We can find the second index by the binary search if the array is already sorted. However, there is no implication that the array is already sorted, so we need to sort the array and find the second index by binary search. So the time complexity could be reduced from O(n) squared to O(n) log n, and however, we need to use additional O(n) space to storing the original index. Can we do better? Actually, we can according to the space and time trade-off. For example, instead of using the binary search to find the second index, we can use a map to record all the elements we've seen before, and the finding the second index could be reduced to O(1) because we already recorded in a map. However, it's actually a trade-off between the time and the space because the map will take additional space in this situation. The fourth method is actually the sort and then use 2 pointers, which we will illustrate in the two-sum 2, not in this problem. Usually, the interviewer will let you implement the method 3 because considering the original array has not been sorted, all other like method 2 and method 4 needs an additional step to do the sort and also additional space in storing the original index because we need to return the original index. So this method, the additional space used to store the index in the map is not that expensive compared to other methods. Now let's take a look at the two-sum 2, where the input array is sorted. According to our previous two-sum, we usually do a sort to make the input sorted, and then we can take advantage of the sorted input to do the binary search or even do the 2 pointers. So here we will still have 4 different methods. First one is same as the before, use brute force to exhaustively iterate 2 indexes, time O(n) squared, additional space O(1). However, we can definitely do better because the input is already sorted, so we can just do the binary search for the second index. So we can reduce the second index time complexity from n to log n, which makes the whole time complexity to O(n) log n, and the additional space is still O(1) because the input is already sorted. And the third method is still use the map to record the number we've seen before. Here is the trade-off is real because we don't need for the method 2 we don't need additional space to store the original index. So here we need to do some sacrifice to create a map to store the space. So the time is O(n) but the additional space is still O(n). And for the fourth method, it's the most magical one, which is the 2 pointers. It will take time O(n) and additional space O(1). Here is the implementation, and there are a lot of available materials about why these 2 pointers work. However, I will provide a very novel way to interpret this, which make us to another, which lead us to this search 2D matrix, because actually we can, because this 2D matrix is very special because the integers in each row is sorted and in each column is also sorted. So we can actually view it as a matrix of the summation of the array in the two-sum 2. For example, here we have an input array. If we do a summation between every 2 elements, we will actually get a 2D matrix which has the same traits as described here. So actually, the best method in the 2-sum-2 is actually the same as the best method in the 2D matrix. But we will still, like, as an interviewee, we will still like always start with a brute force and say like we need to scan the whole matrix to find the number, and the time is OMN, additional space O1. However, we can do better by binary search to take advantage of the input is sorted in each row and column. So if we binary search based on row or column, the time can be reduced to ON log M or OM log N, depends on which one's larger. And the third method is the one we mentioned as in the 2-sum-2, which move from the top right corner, which actually is the same as move 2 pointers on the sorted array. Like imagine that this matrix is constructed by adding every 2 elements in the sorted array, and moving from the top right corner is actually equivalent to set 2 pointers, one at the left and one at right, and gradually move them towards the center. So the time is n plus m, and the additional space is 1. That's the logical chain to chain through all those 3 methods. And next time I will share my takeaway from this, like further proceed to another kind of problem called 2-subject, not 2-sum, but 2-subject, which is a very interesting topic. So subscribe if you want to know more. Thanks. Okay, that's all about today's video. If you feel it helps you, please subscribe and give a like to this video. I will see you next time. Thank you.